All right, welcome back to my operating system hacking and development environment. Today, I'm going to be working a little bit on timer events. It's something that I don't currently have in Serenity. And specifically, I would like to implement a clock widget or clock window in the graphical interface. And I already have a simple clock for testing, but it doesn't actually update automatically. And I'll show you what it looks like. Yeah, so it's right here. And it only updates when I click it. But of course, I would like it if a process could listen or to register a timer, and then it would just get woken up every so often and have a chance to do something. So that's what I'm going to be implementing today, and the architecture that I have in mind is that currently these graphical programs here, they are driven by an event loop, and the event loop and everything is in user space, so it's in the user space program, the event loop, and the graphical actual painting takes place. Um, and I would like to make it so that any object in my, these are called G objects in my libgui, how do I call it, nomenclature or whatever. These things are called G objects, and everything is a G object. And I would like it if I'm going to make it so that a G object can register a timer, and then get a callback every so often. So we would say something like start timer 500 milliseconds, and then every 500 milliseconds, your virtual function timer event gets called. That's what I would like to achieve. And then, of course, in this case, the timer event would call update here on this G widget. And yeah, if you look at if you look at the libgui code, you would probably recognize that it looks very similar to Qt, which is a framework that I personally really like, and I used to work as a developer on Qt a long time ago. So I'm sort of using a very similar API for my libgui. But anyway, then when you register a timer in your G object, what's going to happen behind the scenes is that it tells the G event loop, which is the client side user space event loop, that hey, I'm this object, I have this timer, please wake me up after this time elapses, right? And then the event loop, what it normally does is that it blocks in a call to select, and is just waiting for anything to happen on the file descriptors that that it's interested in. In this case, it's like the keyboard input and the, oh wait, hold on, no, it's not the keyboard input. It's the GUI event stream device that it's blocking on, really. So we are going to have to add a little code there so that the select will have a timeout in case there are any timers. Because if so, we should just have the select called timeout after the next timer is supposed to fire. And then whenever select returns, in addition to checking on the file descriptors, we would also check through our timers to see if any of them need to fire, and if so, fire the timers. And I think that would be a good enough architecture in the event loop on the client side. And then in the kernel, I don't have support for timeouts in select either right now, so that's something I'm also going to have to implement. And the way I'd imagine that would work is just that when you're blocked in select, then what currently happens is that every time the scheduler is looking for a new process to switch to. Then he also goes through all the blocked processes and looks at their block conditions and sees is there anything that we could unblock? And this thing would just be another block condition for processes that are blocking on select. It's like that you would unblock if it has a timeout that has expired. And yeah, so that's basically how I'm going to implement this. So I have no idea how long this is going to take, but let's just get started. All right. So let's go here, and I think we will start in the, let's say in the little, no, it's not clock widget. It's my GUI test 2. This is where I put the little clock thing. So it's a clock widget here. And I already have a timer event, although it's kind of a dummy function. But this is what it's going to do once we actually start calling it. Currently, no one's calling it. We also are calling start timer 250, but obviously, there's no actual timer here driving the thing. And this is just something that I had here since before, because this thing used to have an SDL back when I was testing this out in a Linux environment. So this is some leftovers from that time. So let's go ahead and see. Start timer is a GObject member here, as we can see. Let's have a look at what it does. Does it even do anything? Possibly it really doesn't even. How do we get there? GObject. Yeah. Oh, here, start timer. Right. And timer ID, blah, 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 blah. Let's go ahead and say ginit loop main register timer this, and let's see, say it like that, and also how many milliseconds. Okay, and then we can say so maybe it would be cool if you could have multiple timers per GObject, actually. So I guess that's how it worked in, sort of how it works in Qt, if I recall correctly, and also how it worked in my SDL implementation. So I'm just going to go ahead and do things that way for now. Let's see. I mean, it's not how it worked in my SDL implementation, but it doesn't matter. Let's just have a single timer per GObject for now. And here we would say ginit loop main unregistered timer this timer ID. I guess it's actually even cooler if we make this thing kind of let's see. Register timer. Oh, we want this. Right. And then we would pass the timer ID in order to get rid of this thing. And then, of course, we can't do this before we unregister. Okay. That's cool. And then let's go in the gEvent loop and add these guys. So register timer. GObject. Well, that's implied. I don't like to write out parameter names if it's obvious from the class or context what from the type or context what the function of the parameter is. In this case, it's obvious that it's registering a timer for a GObject. It's some people write this out, and I find it looks so redundant. Anyways, so GObject and int milliseconds. Milliseconds. Okay, there we go. And then also, I guess unregistered timer. Maybe it should return a bool in case it fails, because we could fail if we don't have that timer ID. Okay. And I guess we can just make some struct up for this. Let's say timer. Let's call it an event loop timer. And it would have to contain a timer ID. And it would also have to know the next fire time, I guess. So let's put that in a struct timeout maybe, or let's see, where's this thing defined anyway? Timeout TV. Maybe I can just define it that way actually. Expire or fire time. Yeah, that's good enough. Okay. Time, fire time, and of course, almost the most important thing, perhaps, owner, because he's the guy who's going to get notified. Okay, and I guess we should also have the interval, because when the thing fires, we're going to want to reset the next fire time to happen at the next interval. And oh yeah, and down there is my my Mac OS that I'm using to record. Don't worry about that. Okay, and then let's go ahead and make a map of these, where we map timer ID to an onPutter event loop timer. Okay. I think that's good. We're gonna have to include the hashmap template. Are we good? I think we are good. And that might even be everything that we need. And then let's go ahead and, because I think I'm gonna definitely need this, like, let's see, timeout. Get next timer expiration. Let's say timeout. Right. And then this would be a helper that will help us figure out, like, when's the next timer that's going to fire. Yeah. And okay. And then we're going to go into event loop and have a look here. So, and this is the main loop. This is where we go around and around and around over and over again. Here's that file descriptor that we listen for events on that I mentioned. And yeah, this is the meat of the thing, is that we, if we don't have any queued events, then we wait for event. And this is wait for event, which is, this is the select. Here we do the select that I was talking about. And currently we do either a 0 time select or an infinite time select. So we're going to want to actually do a little bit of thing here. So let's go ahead and say if mTimers, if mTimers is non-empty. Oops, oh, damn, how did I even do that? Okay. If mTimers is non-empty, then yeah, I guess just get next timer expiration time. I didn't even need to have that bool return. Seems silly to even have that, but okay, let's just go ahead and keep it that way for now. Okay, and then we'll say event loop. Okay. Let's call it the soonest. Soonest. Don't use that word very often. Okay, and then let's iterate through the timers. So obviously, like, this could be made, you could optimize this whole thing by keeping an ordered list of timers and stuff, but right now we're not going to care about that kind of thing. We're just going to make the functionality, and that's what's important right now, is just getting things to work at all. And we can worry about optimizing things some other day. So, oh, I guess we're going to have to do that. Yeah. And then if it dot, what is that thing? So timer fire, oops. Fire time, right? If fire time is less than let's just go ahead and assert that we have timers, and then we could let's see if it's less than soonest sec, or yeah, because we're going to have to deal with this case as well. Fire time tsec is the same. Okay, then soonest is fire time. I think really this is all we need to figure out here. Of course, this thing is a little bit broken right now because we're going to be coming in here with soonest already containing zeros. So that's not going to work right. So first thing is we're going to want to do is just, let's just quick hack it. Has any. Has checked any. Just to make sure that we get through here. Okay. Check true. I think that's pretty good. Then we'll get through here, and ideally now timeout will be the next timer event, whenever that is. Okay. Then let's go ahead and write some more functions. G-event loop register timer. So this is one that we need to make. Let's start with that. Okay. So let's just copy this stuff over. We don't know the timer ID yet. Okay. And oh yeah, we're gonna need that as well. So timeout. Get time of day. Like that. Oops. What the hell is the I never remember. It's the time zone is the second. All right. Right. Well, I don't have a time zone, so forget about it. Okay, and then fire time is t. Let's say t dot. Oh wait, why am I doing it this way? Time of day. Yeah, I don't need to make my own thing here. And then we would also do like we have to add a bit to that. Milliseconds. Okay, I think that's cool. And then we're just forgetting about the timer ID thing, right? Let's do that like this. We'll make timer ID, and actually let's just next. It's a little bit lazy. It will eventually wrap around, but I don't care right now. Let's just say fix me. This will eventually wrap around. And what else do we want to do? We want to timers dot set p dot move timer. We want to make sure that we return this actually. So let's say and timer ID. Oops. Let's put that out here. And have to initialize that. Actually, we can just put that in the event loop.h. Okay. Say int and next timer ID. Start with 1. Oops, what the heck? Let's say assert timer ID. Let's be aforementioned wraparound. It's a pretty redundant commentary here, but I'm going to have to do something about that eventually, so it's good not to forget. Okay, because this way it will actually crash once we wrap around, and I will be forced to look at it instead of silently reusing an potentially existing timer. So let's do unregistered timer as well. Okay, and then timer is not defined. Otherwise, let's see, timer's that remove. Yeah, actually, it would be nice if we could remove the iterator directly. I guess HashMap doesn't support that. And the hash table does? I feel like hash table supports removing an iterator. Yeah, okay. And then HashMap doesn't. It seems like an oversight. Let's see. Okay, void remove iterator. Oh, but iterator is defined later, actually. Okay, let's just move it down here. Type. I think that's good. Okay. Okay, I got a little sidetracked here. I just didn't want to remove by key again, because that's going to be another hash lookup. A little premature optimization, perhaps, but I just think that's just good sense to not do multiple hash lookups if you can avoid it. All right, and Oh, here also, let's just assert that milliseconds is greater than 0, because otherwise it's going to be weird. Let's allow 0 timers, but oh yeah, let's allow that. Okay. So now we have all of these functions. I think possibly they might be sort of correct-ish. And yeah, so let's go here. And like currently what we do is that if select returns, we check through the set of file descriptors that we were waiting on for something to happen. And we see if none of them were flagged as like, oh, there's some event pending on one of these file descriptors, then we just return early. But now, of course, we're going to want to look through the list of timers before we do that. So we can't just bail just yet. So let's see. Maybe we could even do for auto t timers. And then let's say auto timer. Timer dot has expired. We're going to make that function soon, don't worry. Timer has expired, then timer.owner. All right, so let's post event. Wait, how does post event work? Post event, receiver, and G event. And it's really only doing this, but let's go through post event anyway. Timer.owner. Make G timer event. Okay. Maybe timer event should have the timer ID. Let's just pass that along with it. Otherwise, it's going to be kind of irritating to later on try to implement. To try to implement multiple timer support. So let's see, let's just put that in a private. So the default and int timer ID const return m timer ID. Jolly nice. All right, so I think that's fine. Oh, yeah, this morning I don't care about this right now. Okay, then we're gonna have to make the has expired function, and of course we're gonna need to look through all the timers because like many timers could expire at the same time. So we just continue through this loop and post an event for each one of the timers that has expired. Of course, it's important that we also reload the timer if relevant, or if it's maybe we should also support single shot timers that get removed from the loop once they have fired. So fix me single shot. So let's see here. Maybe we need to maybe we need one more member actually. Let's call it should reload. Okay, and then in register timer, we'll just say let it be a Boolean parameter, actually. And then people can just decide for themselves. And there was this one place where we were using this, and here we will say that yes, it's reloading, and we can use that differently later on. Yeah, and then we'll just have to add it to the declaration as well. Okay. That's cool. And then if timer dot should reload, timer dot, yeah, okay, so then we have to do this thing again. So let's see. guess we can just put that here. It's a little bit silly. Maybe let's just put that in a helper function actually. So let's go here and write loop event loop timer reload. We'll put this. Let's see, call it reload. Almost expired. Okay. That was not the right return type? Oh, yeah. And then here we'll just say yeah, timer reload. That's good, because then we can just do that here as well. Else, I guess we should. I guess we should just remove it from the. Okay, so we'll deal with these single shot timers later. So we support removing timers, expire timers. Yep. Don't want to do that right now. Let's just worry about this other case. Okay, so we need to implement has expired, right? This is the guy, right? So first thing we do is, I guess, get the current time of day. Now. Of course, this is going to be a little bit inefficient, so really we should probably only call get time of day once, otherwise we're going to get super bogged down in calling get time of day. So let's put that in a member actually. Timeout and now wait and now wait event now wait now. It's hard to come up with a good name for this thing, and time at start of timestamp for timer times processing. Okay, let's just call it that. Oops. Okay, and then here we'll do something like get time of day. Okay, I think that's cool. And then we can just use that everywhere in the has expired at least. Oh damn, but he's not going to be able to reach to there. Gross. Okay, how about we just... Oh god, what's a good way to factor this? How about I just don't try to prematurely optimize this thing right now, and then we'll just do that later. And I just allow it to be slow and worry about that later. Okay, see, I was falling into a stupid trap there. Good thing that we can get out. Has expired. Okay, so if basically the same logic as this, I guess. That if fire time TSEC is greater than now, or if it's the same as now, and the usec is greater than. Wait a minute. I'm doing this backwards. Okay, this isn't what I wanted to do. If now is greater than. Yeah. This is what I wanted to say. And we can even be nice and do like that. Okay. I guess this is exactly what we want to return, actually. Okay. And let's be helpful and print out the thing here. Thing has expired. Notifying. And then this timer ID, timer owner. And we wanted to include the timer ID there in the gtimer event. Right. Okay, actually, let's just go ahead and see if this whole thing compiles the way that it is right now. Do I know my own password? Yes, I do. Okay. Control may reach end of. Forgot about something, didn't I? Yeah, I should be returning the timer ID here and return true here. And then, of course, as I mentioned earlier, we don't have any support in select for this. So here's this syscall handler for select. It says right here, implement timeout support. Let's see. So let's go ahead and say, what did it say here? I guess if timeout and select timeout. Is that cool? How does gettimeofday work anyway? Oh, we don't even get the milliseconds yet. Well, that's just another problem that we're going to have to worry about a bit later. Let's start with seconds. Okay, if we can get this thing to fire every second, that would be a start. So, yeah, so we just have this thing that gets the current time second granularity from the RTC, the real-time clock. We just call it RTC now to get that. Okay, so let's just save this thing that way. Then, and then we have to add that member and process.hm select. Just add this guy right here, timeout. Should probably select as timeout, just to be sure. Okay. True. Okay, because after that, we can now look in the scheduler to look at, so this is where we are looking through all the blocked processes and see if there's any reason to unblock them. So in the case it's in the blocked select state, we look if there is a wake up requested, and then we look at if there are any reading file descriptors that have anything we can read on them, and then any writable file descriptors that look if we can write to them. So I guess we should probably, for efficiency's sake, I like to order these things in order of efficiency, I guess. So let's just look at wait, no, not for. If process.m select as timeout. Oh, it's a little bit frustrating that you can't autocomplete. Why can't you autocomplete? I guess because it's using auto and the IDE doesn't understand. Okay, select as timeout. Process dot select timeout. Right. So we want to check that against RTC now. Now is RTC. Now is greater than mselect timeout tsec. Then process dot unblock. True. Okay. This feels slightly hackish, but I guess it's okay. And oh yeah, we should probably rebuild because I don't really have header dependency management in my makefile here. So since I changed the layout of the process class, I'm just going to rebuild the kernel. It's a pretty fast thing. Okay. So let's just do one of those things where we confidently assume that we took care of everything and just try to run it. And look, nothing happens. Oops, oopsie doopsie. And everything's all laggy and weird. And some timers did expire here eventually. And there were multiple timers. I didn't want there to be multiple timers. Why were there multiple timers? Oh, actually, I guess I have some leftover timers here. I'm just going to get rid of these while I'm testing. Is that one? Oh, there's really only the text box one. Okay. Userland. Okay, I'm going to rebuild everything. Okay, so I had it's a timer in the gtext box class that's supposed to implement like blinking the text cursor, but I don't want that thing to interfere with me right now when I'm testing, so I'm just going to disable that. And let's see, but I guess probably the timeout thing wasn't really happening. Timer expired. Yeah, as you can see, the timers expire over and over, and but only when like I send some input. Also, the clock is going haywire, but I think that's because of Box. Like Box has a very strange real-time clock that sort of doesn't track real time unless you tell it to, but then slows down booting incredibly. So I'm just not using that. But in QEMU, we would see the correct behavior eventually. I'm just using Box right now so that I can look at the debug output. Okay, so we have this problem now that we figure out that the timers expire, all right, but we don't interrupt select call. Let's see. And why is that? Select has timeout. Let me set that to true. Let's see. Yeah, so this thing is not going to have millisecond precision right now, but that's a separate problem, so we're just going to do this thing first. Doesn't seem like we ever end up there. Oh, I think, I recognize this. It's because the G event loop doesn't even pass the timeout to select. Because it only passes the timeout if there are there are no queued events. Wait, if it's no queued events, then we wait infinitely. Otherwise, we wait the timeout. Oh, okay. If there are no queued events, let's go ahead and say no queued events and end timer is empty. Right. So there's literally nothing to do. Make user land. Yeah, I knew I had something for that. Yeah, that's more like it. And look at that. It's actually updating. We're just seeing this thing a little too often. But I guess this is how often it will update. If we let it. Okay, and let's try that out with the real-time clock changed. So I think, yeah, what we do here is we set this option instead, and then it will run in real time, and we should probably see it way less often. We don't. It just gets interrupted all the time. Okay, well, it's progress. At least we know. I can actually leave it like that for now. So timer is empty, otherwise timeout. Okay, and then the timeout is going to be as soon as this fire time. Oh, wait, hold on. It's okay. This is okay. Everything's okay. It just wasn't firing it there. Right. So this thing is printing because it wasn't quite time yet. So let's do something like unblock. Otherwise, stay blocked. Okay. So let's just have a look at this. I think this is all good. Okay. Couldn't open. No. Come on, Boxy boy. Stay blocked. Yes, it stays blocked. Scheduler only wakes it up every so often when the time actually changed. So look at that. It seems like it's working. How very nice. Wow. Okay, so let's go ahead and get rid of this stuff. And so it is a little bit sad that we don't have the millisecond accuracy. And I'm not quite sure what would be the best way to get that. I guess if we would track we would use the timer interrupt that the scheduler uses. So like currently the scheduler has a timer that interrupts every how often? ticks per second is what? 600. So every, wait, what does that mean in practice? 600 ticks per second, okay. I guess it's 600 ticks per second. Does that mean that it's not quite milliseconds? Maybe if we make this into 1,000 ticks per second, we would get a tick every millisecond. Would that even run okay? I have no idea, actually. I'm going to have to test this out. Well, the mouse is all wacky, but let's try it on QEMA to see. Seems fair enough. La, 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 la. We got the timer working here. Okay, so I was just thinking that that we could track every time that we get a timer interrupt, we could increment some global, and then we would know that that's how many milliseconds expired since we started the tracking time. And then we could use that to figure out how many milliseconds into the current second we are, because we would also, like, I think we already remember, like, what time we booted. I think I put, yeah, it's an S boot time here. I can get the boot time, and then the boot time times 1,000. Boot time, yeah, so current time minus boot time times 1,000. Yeah. I think we can compute this thing like this. I always feel like the least confident about like arithmetic. I don't know why. I always feel like I'm gonna mess it up somehow, and I'm not getting it right. I don't know why. But it's always been like that. So let's just go ahead and save this thing somewhere. So this thing fires, and we end up here, and we're in scheduler timer tick. Maybe we can just put that in the. We can just do it here actually. We would say this ticks. Ticks since birth. Ticks since boot. I guess that's a better thing to call it. And let's static keyword. This thing is going to wrap around, but let's not worry about that right now. And let's instead worry about just making it work, and we can worry about the wraparound later. Okay, and then here we'll just say ticks since boot 0. Okay, and then we can also add like a little helper for this guy. It's called like okay, and then PIT. Oh, I82. Yeah. Okay. So let's see now. And should we put this helper somewhere? I mean, I guess process is get time of day This might be as good a place as any. As good a place as any. Okay, so TVUSEC is 6 since boot. What am I trying to do here? Divided by 1,000. That's how many seconds since boot. Okay, let's just compute this sometime. 19 seconds since boot. Oops, that's this. And do we do something like, I mean, I guess we can just do like percent 1,000. I mean, wouldn't this just be enough for these purposes actually? Like, I don't need to get fancy. I just want to know, I just want a number that's steadily increasing. That's sort of roughly. Maybe this will be good enough for me actually. I mean, right now. Probably I was just overthinking it. And let's see, auto now. Auto now. Okay, and then let's see how this thing looked right now. Yeah, that's pretty typical 1 second timer. And let's go ahead and change that. Wait a minute. Yeah, it's indeed only a 1 second timer because right here you can see that it's supposed to run 4 times per second actually. So it's already wrong. Okay, good. It's good because then we know that we have some stuff to look at. Let's start in the G event loop actually. Okay. Select. Get next timer expiration. What are we forgetting? So select timeout. Oh, because I'm a silly goose. I was dividing it by 1,000. That's not what I wanted at all. Yeah, this is what I wanted. Look at that. It's beautiful. Okay. What a silly. Yeah. So let's see if this is firing 4 times per second instead. I would say it looks like it does. Ain't that pretty? All right. The mouse cursor is a little wonky inside box, but generally things seems to be working. Let's run it in QE mode. So just to get a feel for it. Yeah, look at that. Very cool. Maybe we could even re-enable my text box linking code, since we were so close anyway. Let's make it again. It's all looking pretty okay-ish. I think this text message here is definitely going to have to be behind the debug thing eventually. Something like if def load debug, something like that. Oh my goodness, look at that. I have a blinking cursor. It's a little bit slow, but it seems to be working just fine. Well, I guess that's pretty neat. I guess that about settles it. We're already have everything working. So, patch review. Let's just start from the top. In hash map, I see an unnecessary new line is imperative that I remove that. All right, let's start over. Okay, so I don't think I'm going to keep that particular box RC change that I made, just because it's irritating to wait for so long for it to boot, like you have to if you run with real-time clock. But back to the patch. Okay, so here's yeah, so the ticks since boot modulo 1000 is the USEC. And if we have a timeout, then we set it. Set the process timeout to that. Yep. It's all good. I'm just going to leave this change in, even though I would prefer this. But since my IDE gets confused and doesn't autocomplete, if I use auto there, I'm just not going to use auto because I want autocomplete. Okay, so if nowsec is greater than timeout sec, or nowsec is the same as timeout sec, and usec is greater than or equal to timeout usec, that's all good. Then we unblock. Perfect. Tick since boot. Then yeah, right. And now because we do modulo, then it doesn't really matter that much that it will wrap around eventually. I don't give a shit. Yeah, we changed the ticks per second to 1000. I think that's a reasonable, healthy change. I don't know why we were running with 600 before. 1000 should be fine. And then, oh yeah, we pass the timer ID to the timer event constructor. And then the event loop changes. Right, so we're passing the if we have any timers, then figure out when they expire. The next one expires, and then we pass that expiration time to select, so that select can return early in case that timer expires. And then here we look through all the timers after select returns to see if any one of them has expired. Actually, I noticed a thing there that I would actually write this as an early continue here instead, because then we don't have to nest as much. Isn't that nice? It's nicer not to nest so much. And then has expired. Yeah, so here's this thing that I was concerned about, that get time of day would be inefficient, but if it is, then we'll figure that out later and we can just live with it until then. Let's not prematurely optimize this thing right now. Then when we reload, we just add the interval to the current time. It's all good. Then when we're looking for the next timer that's going to expire, we go through all the timers, and then we see if fire time is less than soonest, or if it's the same and the USEC is less, then we copy it over and it's all good. And I think this thing didn't actually need to have a return type, so let's just make it like that. Yeah, this thing was unnecessary, so oops. Oh, goodness, how am I doing that? Okay. There's wraparound stuff. I'll just leave that fix me in there. Yeah, just setting up the timer here and then unregistering timers. It's all good. And class changes to g-event loop, all good. Little event loop timer class, it's all good. This guy is the generator creating the new timer IDs, it's all good. It's just incrementing integer. And yeah, when we stop timer, then unregister that timer. Maybe in gObject stop timer we should assert success. Yeah, because it would be a bug otherwise. Okay. I think I'm pretty happy with these changes. Let's just, after those last changes, let's just do one quick sanity check that it still runs. Come on now. It does run. Clock is ticking. Cursor is blinking. Now it's blinking in the other field. Now in this field. Now in this field. Now in this field. All right. So very, very cool. All that's left to do is just turn this into a commit and say implement event loop timers. This needed a few supporting changes in the kernel. Select now supports arbitrary. And the now takes 1,000 times. The time of day returns something in the USEC field, and let's just it doesn't matter what order they're in. Okay. G-event loop. Well, this will eventually cause G timer events to be dispatched to the gObject. Am I forgetting about any major thing here? I think not really. Is this these changes the clock window in GUI test 2 finally ticks on its own. Okay. I think we're good with that, so we're just going to go ahead and push that to the interworld. And make a little recap here. So I set out to get my clock ticking, and I did. I implemented the event loop timers for GObject, and I implemented the timeout support in the select syscall, and I also added millisecond precision to gettimeofday so that we could have things that tick more than once per second, which is obviously very important to have. And now we have it. So I think that about concludes this hacking session. So I hope you saw something interesting, and thank you for watching, and I'll see you next time. All right.